So 2024 paper here, this question 3, A, B, C and D. So a company sells a range of office supplies and equipment. Shown below is a stapler. In the space provided, draw a well-proportioned freehand sketch of the elevation of the stapler. Yeah, so they want an elevation of it, okay? So you can take your time. So you can tidy that up there, then put a little shade and colour into that. So, the second part there, B then. The image shows a push pin supplied by the company. Shown below is an outline drawn of a single push pin. Redraw the push pin below, rotate it anti-clockwise about point O, okay? Until A reaches this line down here. Okay, so, first thing we need to do, right? I'm going to label my other corners. So A, I'm going to call this corner 1, 2, 3, 4 and 5, okay? The next thing I'm going to do is I'm going to rotate A from point O until it hits that line L1. Okay? Now I'm going to join A to O, and I'm going to get that angle inside there. Right? The reason we're doing that then is because all those points need to move the same angle. So if I measure that angle there then, okay, if you need to extend the line to be more accurate when you're measuring it. That angle there then is 68. So that's 68 degrees, okay? So, it's the same steps now we follow for all of them, right? So, the first thing I'm going to do is I'm going to join 1 to O. Okay? I'm going to measure 68 degrees. So we're measuring 68 degrees. You can draw this line out. Right? So I joined A1 to O, measured 68 degrees to get this line, and now I'm going to rotate point 1 until it hits that line I've just drawn. So you rotate 1. So A is here, 1 is now here. So we're doing the exact same for all the points. So join 2 to O. Then we measure our angle on it. So we get our protractor, measure our angle. 68 degrees. And we can rotate point 2 then until it hits that line. So that now is our number 2. 3, join it to O, measure your 68 degrees on it. Rotate point 3. It's actually the same as 2. So 3. Same with 4. So same with 4. Okay, and once we've all done them down, A goes to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Okay, and then to get the actual pin part, I'm going to measure it here with my compass, the distance from it, the corner of A here, swing it, and we can join that. So that's that question there, then completed. That's it rotated around. So the next one here then is our parabola. So the image shows a design for a blinder clip. The clip includes a parabola DOC with vertex at O. Draw the parabola DOC in the rectangle ABCD. Okay, so the parabola. First thing to do for our parabola, right? We're going across from the vertex, and at this corner we're drawing a line at any angle, any distance. Now on this line we're swinging off how many points we want to divide it into. I'm going to do 3 for this question. So 1, 2, 3. The last point gets joined here with D, and all our other ones then go parallel to that line. Parallel. And they get joined up to the vertex here then. We must do the same on the bottom here now. So angle line, any distance, any angle from D, and we must mark off the same number of points. 1, 2, 3. Our third point in this case gets drawn back to the axis, not to C, back to the axis. And we're going parallel in from there. Okay, these lines then here go parallel with the axis, which is just straight up in this question. We're finding our points out there. Okay, and we can mirror then across this line. We can do this again over the other side, but just to save us time, we're bringing these points across. Point of the compass goes on the axis. Extend it to wherever the point is here on this side. Turn it around, swing it on the other side. Same over on this side, and swing it in here. We can draw it. So that's that question there completed then. So the image across shows a pin holder. Shown below is the plan and incomplete elevation of a similar pin holder, filling the missing word in the sentence below. The pin holder is a truncated square-based prism. Complete the elevation of the pin holder from the given plan and find the true shape of surface S. Okay, so to complete the elevation, we're just bringing up our corners here. Okay, so we're seeing this, that's the front, so it comes across, this goes across to the back corner here. We can join these two. This is solid, down to, because it's truncated, because it's cut, and then dotted down, and we can just darken this bit in as well. So that's the elevation of that completed. Now we have to find that true shape of S, okay? So I'm going to use that row battlement method, alright? So we need to figure out first where is S in plan. So this is it here. So if we drop this down, this is S here in plan. This line, okay? So that's S. Alright? So from one of the corners of S, I'm going to draw a line parallel with that XY line, which is just a straight line in this question. I'm going to put the point of the compass there at the end of S, extend it to the start of S, and rotate it around. Now I'm going to bring up that corner here. I can bring across this front height, join this up to the back. So that's now my true shape of surface S. So So that's that question there, the incomplete 2024 junior cert paper.